Hi guys, in this video I will show you how to get started with the ESP8266 using the Adafruit Huzzah breakout board. The first thing you will need to do to be able to connect to your ESP is to solder on the headers on the breakout board. Once you have that, you will need two things. The first one is a console cable, and depending on whether or not your console cable provides power, you may need an external power supply. This was the case for me. My console cable only provided 3 connections, the serial connection and the ground, but no power, so I connected an external power supply. The breakout board supports inputs up to 16 volts. Once all connections are made, you can try to connect using the command line. In Windows you could use PuTTY, and on Linux and Mac you can use the screen application. Make sure you use the correct serial interface on your machine and ensure that the baud rate is set to 9600. If you don't see anything, try pressing the reset button on the breakout board. You should see the command line. You will need two things to flash your ESP. You will need the firmware file and a tool called ESP tool. The links will be in the description. To enter programming mode and be able to flash your ESP, you will need to press the reset button while holding the GPIO 0 button. You will notice that the GPIO 0 LED remains lit on, and you can then start the flashing procedure. Flashing the module takes about 1 minute and is particularly useful to recover from broken code in case your ESP is stuck in an infinite loop, for example. Once flashing is done, you should be able to connect to your ESP module. If that doesn't work, try pressing the reset button again. You could program your ESP using the command line. There is, however, a Java application called eExplorer, which makes it a lot easier. The application provides syntax highlighting and plenty of other features, such as loading the code onto your ESP, saving it to the ESP, for example in the init.lua file, which will load the code every time the ESP is restarted. If you made a mistake and cannot reprogram the ESP, you will have to flash it using the procedure demonstrated before. In this instance, I wrote a program which simulates an IoT doorbell. When the GPIO 0 button is pressed, it triggers an event using the if this then that service and results in a notification on my phone. You can find the code in the blog post on my website. Now that the ESP is programmed, it's time to set up the if this then that recipe. The recipe consists of two parts. The first one is the trigger, which is the maker channel. This allows you to trigger an event using a custom URL. The second part is the action, and in this case it's a simple one, is the notification. This will trigger a notification to the if this then that application on your phone. You can customize the message of the notification depending on your application, and once everything is correct, you can create the recipe. Okay, time to demonstrate what we've just programmed. The first thing to do is to connect the ESP to a power source. In this case I'm using jumper wires connected to a barrel jack adapter, which will then be used to connect a battery pack. I'm using 4 AA batteries to power the ESP. Remember that you can use any voltage between 3.5 and 16 volts. When we press the button on the ESP, it triggers the event and should result in a notification on the phone. As you can see, the responsiveness is quite good. It takes a couple of seconds for the notification to arrive on the phone. Okay, that's it. Remember to check out the blog post in the description. It contains all the code and links to the different applications used in this video. Don't forget to like and subscribe if you would like to see more in the future. Thanks for watching.